going to be working on is we're going to continue to work on applying trig functions. All right, on problem number 7, they have not given us a picture, so we need to create a picture to go with the problem. All right, so the very first thing I would like you to do, to the best of your ability, I simply want you to draw a circle. So right now, I'm going to do the best I can to draw a circle. Now, I have a little bit easier job doing it because I've got a cool tool too. All right, now, the next thing I want you to do after you draw your circle is carefully, from the middle of the circle, I would like you to draw a diameter going perfectly across. All right, nice diameter going across. All right, you'll see why I'm doing that. Now, I realize you guys don't have this tool that I'm about to use called a protractor, but right now, I'm going to use a protractor, and from the center, I'm going to do my best to do a 60-degree angle, and I'm going to put right here a point right here at 60 degrees. Then I'm going to rotate it to 120 degrees. Put another point. Okay? Then I'm going to rotate my protractor upside down. All right? And right here, I'm going to put a point. And then I'm going to rotate it over here to 60 degrees. About right. Put a point. And I'll move my protractor away. And now I'm going to create lines going through those points. And then ask yourself, how many equal sections does it look like we have in the circle? 6, right? Now, after you've done that, what I want you to do is I'm going to connect from here to right here. Oh, there. And what am I building? What polygon am I building? A hexagon. So I'm building a regular hexagon. Oh, my board's reset. So my board has to reset. And you do the last section right here. Now, by the way, what do all of these triangles appear to be? What kind of triangles does that even appear to be? Equilateral, right? Equilateral triangles. Well, guess what? A regular hexagon always breaks into equilateral triangles. How many equilateral triangles do you have? 1, 2, 3, 4, 5, 6. Now, what's special about an equilateral triangle? All the sides are equal and all the angles are equal. So if you guys wanted to, you could put, hey, this is going to be 60 degrees right here. This will be 60 degrees, and this right here will be 60 degrees. Now, when it says a circle is circumscribed about a regular hexagon, that means a circle is going around the hexagon. So we have drawn a picture that represents the problem. Okay? Now, it says that we've been given what? We've been given an apothem. Okay? I'm going to highlight this in green because an apothem is from the very, very, very center of your polygon straight down to the middle of one of its sides. And it says the apothem is equal to 4.8 centimeters. So I'm going to label my apothem 4.8 centimeters. Now, if this was 60 degrees in this corner, and over here it is 60 degrees, but what have I done? I've split that perfectly in half. What are these angles right here? 30 degrees. I'm going to put 30. I'm not going to label it twice. Both those are 30 degrees. Now, Joshua, what I'm going to do is I'm going to highlight one of the triangles that we're going to really focus in on. So I'm just going to highlight this one right here. And this right here is a right triangle. Because if you go straight down the middle of that side, it's going to make a right angle. So I'm going to make a bigger triangle so that we can see it so you don't have to squint. Your eyes don't have to squint. So let's pretend right here that's the same triangle. I'm not going to shade in everything orange, but let's say this triangle is the same as this one. Okay? So what's this distance from here to right there? That's going to be 4.8. This angle right here is 60 degrees, and this angle right here is 30 degrees. question asks us this. Find the what? Find the radius of the circumscribed circle. Well, let me explain. That radius could be from here to here. That's a radius. From here to here. That's the radius. All the way around. So you could find any one of those sides. We're just using this triangle right here. So the hypotenuse of this orange triangle actually is what? The hypotenuse of the right triangle is the length of the radius that we need to find. So put R and label it the hypotenuse. Now, we could use the qualities of the 30, 60, 90 right triangle to solve this, but I'm not going to because we want to practice our trig functions. Okay? So, I'm not going to use the properties of the 30, 60, 90. We're going to actually just use trig. We're going to go from this perspective right here. We're going to go from the 30-degree angle. So I'm going to shade this in right here. We're going to go from 30 degrees. Now, the first thing that I'm going to do is I'm going to draw an arrow going across. And what does that help me label? That makes me label this side my opposite side. If this is my opposite side, and that's my hypotenuse, that means my 4.8 represents my adjacent side. Then we ask ourselves, so what do we have and what do we need? We have our what side? We have our adjacent side. What do we need to find? We need to find our hypotenuse. So which one deals with an adjacent side and a hypotenuse? That is equal to cosine. That's why we choose cosine in this particular case. Because we have the adjacent side and we need to find the hypotenuse. So we would say the cosine of what angle of the 30-degree angle equals my adjacent side, which happens to be 4.8 centimeters, over my hypotenuse known as R. And R represents the what? The radius of the circle. Simply place this over a 1. And what have we created? We created a proportion that we can solve for. And what do we always know about all proportions? That the cross products will be what? They'll be the same. They'll be equal to each other. Okay? So let's think about what the cross products are. What's 1 times 4.8? That's pretty easy, right? Just 4.8. What is R times the cosine of 30? Well, we would write that as R times the, we put a little dot here so you know it's multiplied by the cosine of 30. Now I'm not going to put a degree symbol because you don't have to put a degree symbol in the calculator. Okay, I'm just going to understand that's always going to be what? Whatever's inside of parentheses always represents the measure of the angle. Now, we need to find what this number is. So if we were trying to find what R is, what are we going to have to do to both sides to solve for R? Divide. We have to divide this side, and we have to divide this side by the cosine of 30 degrees. Now, Adam, yesterday we talked about something that's very important. If you don't do this, it's going to mess everything up. The calculator needs to be in what mode? Degree mode. Okay? So I want you to understand your approximate value for R in the calculator will equal 4.8 divided by the cosine of 30 degrees. Okay? So we're going to do that in the calculator right now. We're going to turn the calculator on. Oh, oops, I already have to clear it out. Alright? Make sure, check your mode before you come into the class, because somebody might change it back to radian mode. They're being mean. Alright? Do 4.8 divided by cosine of 30. You get 5.54. Just going to round to the nearest 10. Call it 5.5 if you want to. Okay? So you go back. Go over to our say our radius of our circle is approximately equal to 5.5 centimeters. Okay, so this radius right here, everybody, is 5.5 centimeters. Which means our answer for the very first problem, find the radius of the circumscribed circle. The radius is approximately equal to a little double squiggly line, 5.5 centimeters. Now, this is kind of funny. It says, what is the length of a side of a hexagon? That's right. It has to be, because we're what? This is all equilateral triangle. So if this side is 5.5, then this side would have to be 5.5, which means this length from here to here, or from here to here, all the way around, would also have to be 5.5 centimeters. That's why it's useful to know that hexagon breaks into what? 6 perfect equilateral triangles. Now, what's the perimeter of the hexagon? How many sides does a hexagon have? 6. So we have to use 6 sides times the length of one side. And what's the length of one side? 5.5. There you go. So 6 times 5.5 centimeters. So our approximate perimeter would be 33 centimeters. Okay? So, this one was trickier because what? They didn't give us a what? They didn't give us a picture. We had to create a picture based off of the information. That's what I wanted to have practice do.